Welcome to the another lecture of basics of electrical engineering. So continuing from the last class, like last class we talked about uh, sign of battery and sign of uh, IR drop. So continuing from the last class, now I have given a circuit. So in the circuit, you can see there are A, B, C, D. There are four junctions. You can say that four nodes. So in these four nodes, some current is coming and some current is going, and we connected. There are four resistors R1, R2, R3, and R4, and two batteries are connected. So in this AB branch, let's I have I1 amount of current is flowing. So here this I1 amount of current is flowing, and from BC branch I2 amount of current is flowing, and in CT branch I3 amount of current is flowing, and here in DA branch I4 amount of current is flowing. Now using the method we taught in the last lecture, so how to find out what is the voltage across AB. So first thing is that we need to find out in which direction current is flowing. So first we need to calculate the voltage across AB. So you can see here the current is flowing from A to B. So the current is flowing from A to B. That means the current will enter to the resistor R1. So the entering is plus, the leaving is minus. So here I1 amount of current is flowing and the resistance is R1. So the drop will be I1 into R1. The drop will be I1 into R1. So as you go from A to B, and here the thing is that which direction you will take your motion. Okay, I am taking my motion is in a clockwise direction. So I am taking my motion is in clockwise direction. So this current direction is only giving the plus minus sign. Then we will see the motion. So here in this branch AB, my motion is from A to B. So this is my motion. This blue line will show the motion. So when I am going from A to B, it will going from plus to minus. So when I am going from plus to minus, there is a we are losing something. So the voltage will be minus I1 into R1, minus I1 into R1. Similarly, if we go to the branch BC, first we will count which direction current is moving. So in the branch BC, I2 amount of current is moving from top to bottom. So when it is moving from top to bottom, so they enter to the resistance. So entering is plus, leaving is minus. So and this is V2 is the voltage source. We know this is the positive end of the battery. This is the negative end of the battery. Now this current I2 is flowing through R2. So the voltage drop I am getting here I2 into R2. Okay, I2 into R2. As our motion is in clockwise direction, I can show you again. So in the branch BC, I am moving in this direction from top to bottom. So when I am moving from top to bottom, so I am going from, so in this resistance, I am going from plus to minus. That means we are fall in the voltage, so it can be written as minus I2 into R2. Then again in the voltage, I am going from plus to minus. Again in this voltage, so I am going from plus to minus. So again there is a drop in the voltage, so I will get minus of V2. Okay. Similarly, if I go to the branch CD, I need if I go to the branch CD, you can see here. So the current is moving from D to C. The current is flowing from D to C. So if the current is flowing from D to C, the current is entering to the resistance. The entering is positive, so leaving is negative. Entering is positive, leaving will be negative. So we'll put the sign plus minus. As I3 amount of current is flowing, so the drop will be I3 into R3. But our motion is in clockwise direction. So again I'll give the direction of motion is that. So my direction of motion is from C to B, C to D. Remember, my direction of motion is from C to D. So in this case I am going from minus to plus. There is a increase in voltage. So rise in voltage. So I am going from minus to plus. So I can write down. So this will be I3 into R3. So in similar fashion, we can find out the voltage drop across DA. So if I will find out VDA, You can see here. So in this branch DA, the current I4 is moving from D to A. The current I4 is moving from D to A. That means from bottom to top. So the current entering to the resistor is plus, leaving is minus, and as this is a DC source, we know this is minus end, this is the positive end. Okay, so the current is only giving the direction. So here I4 amount of current is flowing across R4, so the drop will be I4 into R4. Now our motion is in clockwise direction, so I can see here, this is my motion, this is my motion. So I am moving from D to A. So first I will get this voltage. I am going from minus to plus. That means we are gaining something. So I can write down here. This is plus B1. Then again I am going from, in this resistor I am going from plus to minus. I am going from plus to minus. That means there is a voltage drop, or I am losing something. So I can write down minus I4 into R4. Okay. So this is a part of a circuit. This is not the whole circuit. This is a part of circuit. So in this branch AB, BC, CD or DA, we can calculate the voltage in this way. Suppose I will take a practical circuit. Suppose I am taking a whole circuit. Let us think that I am taking the circuit like this. Suppose there is a voltage source here. Let the voltage source given as V, and I am taking one resistor. Let this is R1. Another resistor I am taking as R2, and I am completing the circuit. Okay, so let us modify the circuit little bit. I am connecting another voltage source. I am connecting another voltage source in this way. Let this is your V1, this is your V2. Okay, so now I do not know what is the value of V1 and what is the value of V2. So first thing is that we have to assume the current direction. Let us, I am assuming the current is flowing in this direction. So let the current is flowing in this direction. Okay. So by taking the assumption, we have to calculate the current. If I am getting the current, if I am getting the current value is positive, then we think that my assumption is correct. My assumption is correct. If I am getting the current value is negative, then my assumption is wrong. Then the current is flowing in opposite direction. The current is flowing in opposite direction. Okay. So if we do not know what is the current direction, we can take the current direction, where we can assume the direction. After that we can calculate. If I am getting the positive, then my assumption is correct. If I am getting negative, then my assumption is incorrect. Current is flowing in opposite direction. Now you can see here, in this circuit, if we will solve, then I1 amount of current is entering to this resistance. So I will get here, entering means positive, leaving means negative. Same amount of current also enter to the resistor in here. So it will be plus, it will be minus. So here the drop, so I1 amount of current is flowing. So resistance will be R1, so IR drop will be I1 into R1. Similarly here, I will get I2 into, sorry, I1 into R2. I1 into R2. You can see here, you get I1 into R2. Okay, and this is the battery. We know this is the positive end, this is the negative end, this is the same thing. Now comes to our motion. In which direction you want to take? Suppose I want to take in the anti-clockwise direction. I want to go in the anti-clockwise direction, and I want to write the KVL. Okay. So mostly if you do not know KVL, I can say this KVL or KCL in the further lectures. So if we apply KVL, I can start from any of the node or any of the point. So I'm starting from here. I'm moving in the anti-clockwise direction. So where am I moving in the anti-clockwise direction? So first I will get this voltage. I'm going from minus to plus here in this direction. I'm moving. So I'm going from minus to plus. So minus to plus means I'm gaining something. I will write down plus V2. Then when I reaches here, then I will go from minus to plus. So minus to plus means again I am gaining something. I will write down the drop I1 I'll write on the drop I1 into R2. Similarly, when I'm reaches here, I am going from minus to plus. That means gaining something. I'll write down the drop will be minus I1 into R1. Then when I reaches in this last voltage source, I am moving from plus to minus. So plus to minus means I am losing something, or in the fall in the voltage. So I can write down minus V1 equal to 0. Okay, minus V1 equal to 0. So the question is, if you go in the opposite direction, if your motion is the clockwise direction, then also you will get the same answer. So if you go to clockwise direction also, you will get the same answer. Okay. So further things, so regarding the circuit, we will discuss in the KVL once the KVL is over. Thank you for listening.